In this video, I'm going through P2 textbook and it's chapter 2 and the last section, which is section 2.5. So obviously there are still circle theorems that you need to know, at least one circle theorem that you need to know. And a few more details. So a triangle consists of 3 points called vertices. It is always possible to draw a unique circle through the 3 vertices of any triangle. This circle is called the circumcircle of the triangle. So you draw the triangle first, and then you draw a circle that goes through the 3 points. The center of the circle is called the circumcenter of the triangle, and is the point where the perpendicular bisectors of each side intersect. So the perpendicular bisector of the side, so this is a side of a triangle, and the perpendicular bisector would be the dotted line. This might be the other side of the triangle, and the perpendicular bisector of that line would be the other dotted line, and where they meet is the center of the circle. That's what they are saying, and that is what this is about. So you've got 2 perpendicular bisectors, this one and that one, and where they meet is the center of the circle. Now, the other circle theorem that you must remember is that the angle subtended from the semicircle is always a right angle. Basically, the angle opposite the diameter. That's what we are talking about. The angle opposite the diameter is 90 degrees. So if you at any point want to check whether a particular line is a diameter, you check whether the opposite angle, the angle made by the other 2 chords, is 90 degrees. And we're starting here. So the points A, B, and C lie on a circle as shown in the diagram. Show that AB is a diameter. If AB is a diameter, this means that the angle opposite is going to be 90 degrees, which means that AC and AB must be perpendicular. So for AB to be the diameter, AC must be perpendicular to BC. So we really need the gradients. We need the gradients of AC. So I'm going to say, so that's the gradient y2 minus y1 over x2 minus x1. So that's the formula for the gradient. I'm going to put it here. I'm going to take that to be y2. So 9 minus 1, and then minus 4 minus 8. So this is 8 over negative 4 plus 8 is 4. So that's a 2. And then I'm going to do the same. I want the gradient of BC. I'm going to take 9 as the y2 as well. So 9 minus 5. And then negative 4 minus 4. So 9 minus 5 is 4. Negative 4 take away 4 is negative 8. So the gradient is negative a half. So since the gradients multiply to make negative 1, therefore AC is perpendicular to BC, and AB is the diameter. So that's part A. Part B says find an equation of the circle. Well, for me to know the equation or find the equation of the circle, I have to have the center, because I want the coordinate for the center, and I also want the radius, because the equation of the circle looks like this. x minus x1 squared plus y minus y1, let's put actually a and b squared equals the radius squared, with the center being AB. Okay, so to find the center, we need to find the midpoint of AB. So going back, the midpoint is x1 minus 8 plus 4 plus x2 over 2, and y1 plus y2 over 2. So that's negative 4 divided by 2, which is negative 2, and that's 6 divided by 2, which is 3. And to find the radius, I can go from the center to any of the points, and I'm going to choose point B. So to find the radius, I use the formula for the length of the line. So I've got B is 4, 5. Let's just check. Yep, 4, 5. So I'll call that y2, y1. So 4 minus 2, because we subtract, plus 5 minus 3 squared, and I put that into the calculator. So 4 plus 2 squared plus 5 minus 3 squared, and I get a radius of 2 root 10. Now remember, I need to square it, because the formula for the circle is the radius squared. So if I square it, gives me 40. So the equation of the circle is, it's going to be x minus 2, so that's going to make it a plus squared, plus y minus 3 squared equals 40. And that's the equation of the circle. And the second example says the points P, Q, and R lie on a circumference of a circle. The equation of the perpendicular bisector of PQ is y equals 2x. Find the equation of the perpendicular bisector of PR. Now, the diagram did not exist. I've put that diagram in because I wanted to imagine where these points are. So I started with drawing a grid, xy, and I just sketched them. So negative 7 was going to be in the negative x-axis, and then 11q is the far right of the x-axis, and P has the highest y-coordinate, the biggest y-coordinate, so it's the highest value on the y-coordinate. So I just plotted them, and then I plotted or sketched. I sketched y equals 2x, and I also sketched the perpendicular bisector of RP just to see how it looks like. So the perpendicular bisector of PQ is y equals 2x. And then it said find the equation of the perpendicular bisector of P to R. So P to R, I can find the gradient of P to R. So the gradient of P to R is going to be 16 minus 6 over 3 minus 7. So 16 minus 6 is 10, 3 plus 7 is 10, so this is 1. That means that the gradient of the perpendicular bisector it's perpendicular, so it's going to be -1. And of course, the perpendicular bisector goes through the midpoint of PR. So it goes through the midpoint of PR. So I need to find the midpoint. So that's going to be -7 plus 3 over 2, and then 6 plus 16 over 2. So -7 plus 3 is -4, divided by 2 is -2. And then 6 plus 16 is 22, divided by 2 is 11. So now I can find the equation y minus y1 equals mx minus x1. Of course, this is x1 and y1 for our purposes now. So this is y minus 11 equals -1x minus -2. And I'm just going to put plus 2 here. So y minus 11 equals -x minus 2, because I'm multiplying the -1. Y equals -x, and then -2 plus 11 is a +9. So that's the equation I want, and you can write it as y equals 9 minus x if you want. So I found the equation of the perpendicular bisector. I'm going to put it here. So y equals 9 minus x. Part B says, find the center of the circle. Well, the center of the circle is where the two perpendicular bisectors meet, and we have both of their equations. So that's a very simple simultaneous equation. B equals, so you've got y equals 2x and y equals 9 minus x. You equate them because they both start with y. So 2x equals 9 minus x. I'm going to add x to both sides. 3x equals 9, which means x equals 3. And then I want to find y, because I'm trying to find the center. Y equals 2x, therefore y equals 2 times 3, which is 6. So the center of the circle is 3, 6. And then of course it says work out the equation of the circle. So I've got the center and I need to find the radius. So I'm going to go, it doesn't matter really, you can go from the center to Q, the center to P, the center to R. I'm just going to go to Q. I'm going to find the radius from the center to Q. So C, I want to find the radius, and Q is 11, 12. So I want 11 minus 6 squared plus, is it 11 minus 6? No, that's x. 11 minus 3 squared, and then 12 minus 6 squared. And I put that into my calculator. 11 minus 3 squared plus 12 minus 6 squared, and that gives me 10. So the radius is 10. Of course, I want the radius squared. So the equation of the circle is going to be x minus 3 squared plus y minus 6 squared equals 100. And if you want to find the radius squared straight away, you probably can just take that out. So if you put the radius squared and put the workings without the square root, you will immediately get your 100. So this is section 2.5.